Hello viewers, welcome to part 2 of this video lecture. In this lecture we are going to discuss few methods related to designing of traffic signals, and we will start with the approaches or the procedure by which the traffic signal is designed. So we have two approaches. The first one is related to approximate designing procedure. It means we assume certain things to design our traffic signals. Okay, whenever we assume certain thing like this is the input parameter, basically we analyze this input parameter. Based on this input parameter we design this system, and this system is related to your traffic signals. Okay, so based on input parameter, and these are some assumptions. Okay, these inputs parameters are some assumptions. So this type of procedure is known as approximate design procedure, whereas we have another method which is rational approach, which say that you have to design your system uh, in a manner that it will be scientifically correct. Okay, so in rational approach the input which you are taking is based on scientific data, and the logic by which you are designing is also scientifically correct. So these are the two approaches for designing your traffic signal. Let's consider the first method, which is trial cycle method. In this video we only limit to this method. For simplicity we use two phase diagram. Now we move to the phase diagram. We already discussed in last video, but here we clear once again. Suppose, consider this figure. This is a traffic signal lightning for road 1. Okay, so we will start with the red time. So this length shows the timing of red light in second. Up to this value the vehicle on road 1 will face red time. After this we have another zone which is red amber time. I will explain this red amber time to later, but after the red amber time we have green time. So this is your green time in second, and after the green time we have another amber time. Okay, so we have two amber time. The one is your red amber time, which is the transition between red time and green time, and another we have this amber after the green time, which is also known as the clearance time. Now I will explain you how this clearance time will work. Assume this is your road. This is your road 1. Okay, so this is your road 1. Okay, this must be your stop line. This must be your stop line. Suppose let me take this time to you. Here is the time 0. At this position the time will be 10 seconds. This is 12 seconds. After, when it reaches to here we will provide 20 seconds, and this is a 22 second. Okay, so the total length of this signal in second will be 22 second. Out of this 22 second, 10 second consider for red time, 2 second for red amber time, and 8 second for green time, and remaining 2 second for amber time. Now consider a vehicle which is just at the 21 second, this 21 second of the traffic signal. Okay, so 21 second of the traffic signal will lie in this region. Okay, so this is a vehicle which is just away from the stop line and inside the intersections. Okay, so this amber this 2 second is given to this one vehicle so that it clear this intersection. Okay, so that's why we call this amber time as a clearance time, because it allow those vehicles which just cross the stop line and entered in intersections so that they can clear the way for road to traffic vehicular. Okay, so this is the concept of this one amber, and the red amber is the indications of green time must be appear. So this signs is for your uh, this sign is for your road 1. Now we move to the road 2 case. Whenever there is a red time on road 1, there must be green time on road 2 in such a case that this is your green time. So this green time is here is 10 second, which is similar to the red time. After the 10 second, we have 2 second amber time. This is your amber time, or you can say that this is your clearance time. After 2 second, we have 8 second of red time. Okay, we have 8 second of red time, and after 8 second we will move to the 2 second of red amber time. So basically you can see that if the vehicle stop on road 1 from 0 second to 12 second, so it means the vehicle moving on road 2 between this time, which is 0 to 12 second. So basically this is a phase diagram. Phase diagram is related to the signal phase condition. Okay, so I hope you clear this phase diagram. We have different phase diagram also, like phase 3, phase 4, but that will be very complicated for initial state. So whenever you learn this first phase related to two phase and the simple intersection which we designed here, which we draw here, then you will be able to understand that what are the three phase diagram, what are the four phase diagram. Okay, now I rub this content. So we have first method is trial cycle method. For this method we are going with intersection having two roads. So this is your road 1 and this is your road 2. Okay, and we can say that these are the four legs of intersections. This is A, B, C and D. Okay, so these are the four legs of intersections. Now I have provide four different signal like this. This is traffic signal for A leg. Okay, so whenever the vehicle moving in this direction, it will look at this TSA. Okay, so in simple word you can say that this TSA, traffic signal for leg A, is similar for traffic signal at C. So this is useful for this one direction. Similarly we have traffic signal B for this one movement, and those vehicle which is moving in this direction will get the information from traffic signal D. So for four leg intersection we have four traffic signal, but out of these four signal, two are identical. Okay, so whatever the information is for A leg traffic will be same for the C leg traffic. Okay, suppose consider there is red light here, means there is red light at this signal also, which allow that you will not able to move. Suppose this is a stoppage line, so the vehicle cannot pass this stoppage line. Only vehicle move in this directions. Okay, so means if there is a red light at signal TSA and TSC, so there must be a green time, or the green light will appear on TSB and TSD, so that the movement will occur in north south directions. Okay, so this is the condition number 1. Now we move to the condition number 2. In condition number 2, the green light appears on traffic signal A and traffic signal C, means there must be red light for traffic signal B and traffic signal D, which means there is no movement in the direction of north south, so the movement will only occur in the direction of east west. Okay, so this is the meaning of traffic signal, that how they will work, and this figure is useful after the solution of any numerical. So please refer to this condition, how we will work on this. Now move to the basic concept of trial cycle method. In the trial cycle method, the first thing we will assume count. The first step is we will count for 15 minutes. Okay, so suppose this is your 1 hour duration. Okay, this is the 60-minute duration. We will count the traffic for only 15 minutes. Okay, so we have 4-legged. So suppose the traffic flow in the direction toward east will be 100 vehicle per hour, or we can say that 100 vehicle per 15 minute. Okay, so for your correct value we will get this 100 number of count per 15 minute. Okay, so this is the value of 1 leg. Similarly, there is a value of this 1 arrow which is moved toward the west directions. So let's take this is a 120 vehicle per 15 minute. Okay, per 15 minutes. Okay, so you will take the maximum of this value in the direction of east west. So in that case, road 1 maximum flow represented by n1 is equal to 120 vehicle per 15 minute. Okay, so this is the maximum value for 15 minute at road 1. Similarly, we have n2 which is the maximum value for 15 minute, maximum value of traffic count for 15 minute. Okay, so I will take this any random value like this 200. So you can see that in this case n1 and n2 are your count. So this is a step number 1. Okay, so this is a step number 1. After that, we assume the average time headway between vehicle is 2.5 seconds. Okay, what this second step means, this is say that this indicate that suppose this is a road 1. In this road 1, this is vehicle 1, vehicle 2, vehicle 3, like this. These are vehicle approaching to the intersection, and in this direction like this one. So a vehicle, the front of a vehicle, this is the front line of a vehicle, and the front line of b vehicle. The time taken by the v vehicle to cross this line, which is the front line of a, is known as time headway. The time taken by the v vehicle to cross the head line of a vehicle is known as time headway. And the space between these two lines in terms of meter, okay, space between these two lines in terms of meter is known as speed headway. So we have two type of headway. The first one is related to your space headway considered in meter, and another one is time headway which is considered in second. So basically this is the meaning of time headway. Okay, so we assume this time headway is 2.5 seconds. Third step says that assume the total cycle length is C1. This C1 must be in second. Okay. So what do you mean by the cycle length? Cycle length is the summation of red time, red amber time, green time, and again the amber time. Okay. So assume that you have a cycle length. This is your step third. Step third, you have to assume your cycle length like C1. Let's assume that this is a 20 second. So this is the one complete, this is the time taking for one complete revolution of signal. Okay. So if you have 15-minute approach, because you have already counted number of vehicles for 15 minutes. So can you tell me that how many number of this C1 will appear in this 15 minute? In this 15 minute, there are 15 into 60 second, and we have cycle length which is equal to 120 second. With the help of the calculator, if we solve this value like this, the 2 will be equal to 15 by 2, which is equal to 7.5 times. So this is the number of total cycle. 7.5 is the total number appears in this 15 minute. Okay. So basically this is the use of the cycle length by which we will adopt our green time. Okay. So there are 75 times. Okay. Out of this 75 times, we have 4 different times. Like first one is related to red, then red amber, then green time, and the last one is amber. Okay. So every time when the signal is repeat itself, this time which is 120 second, for this case we assume that this is 120 second, this 120 second will be divided into 4 time, and this is our 4 different times. So this is the basically the step third, which is written here. And the last step is you have to find the green time. Okay. So green time is basically, see, let me clear you. This is 15 into second divided by C1. It is the total number of cycle appears in 15 minutes. Okay. And green time is the time provided for the vehicle who will clear the intersection. And we have N1 vehicle in 15 minute count. We have N1 vehicle for road 1, and the average time headway between these vehicles is 2.5. So basically 2.5 into number of vehicle will give the total time by which these N1 vehicle will cross your intersections. Okay. So this is the formula written here. Let me explain with this figure to you. Okay. So suppose there are 4 vehicles A, B, C and D. Okay. So these are the N1 values. So N1 means 4 vehicles per 15 minute. These are your 4 vehicles. Now how much time these 4 vehicles require to cross this intersection? To cross this intersection, like from this position to this position, this is the intersection length. Okay. So how much time these 4 vehicles required? Because we already says that if B1 appears to this one position, it takes 2.5 seconds. Similarly, C1 appear to this B1, it will take 2.5 seconds. After this will take 2.5 seconds, and similarly. Okay, so this is the headway, this is the time headway. Now we have four vehicles. The first one vehicle cross at 0 time, another one will cross at 2.5 second, third one 2.5, fourth one 2.5. So basically we are just multiply our time headway with number of vehicle by which we will get our total green time for this leg 1, so that these 4 vehicles will cross this blue line, okay, along the blue line and cross this intersection. So basically this is the fact, this is the uh, clarification that how the time headway is utilized with the number of count. Okay, similarly we will find G2, which is equal to 2.5 multiply n2, okay, number of count in 15 minutes. Similarly number of cycles, okay, so number of cycle we will obtained by the multiplication of 15 minutes with second divided by c1. Put this c1 to this value. Okay, so why we will find this g1 and g2? Because this is very scientifically, we are saying that this is a rational method. So scientifically what we are doing, the number the number n1 and n2 are different. So the bigger n, the bigger value of n1 or n2 get the bigger value of g1 and g2. In simple word, we will allow green time more for those road which contain heavy traffic. Okay, so by by this value we will find our g1 and g2 value. Now we have our calculated cycle length, which is equal to g1 plus amber1, g2 plus amber2. Okay, in simple case we can say that this g1 and a1 will give the value of r2 plus red amber, okay, and g2 plus a2 will give the phase diagram 2 value, and this the total length for the phase diagram value will be equal to c dash, which is equal to phase 1 diagram length. Okay, so in this case we will find that our assumed cycle length is equal to our calculated cycle length or not. If it is equal to, then our procedure is okay, otherwise we will assume our C again and repeat this all process. That's why this is known as trial cycle method, because you don't know that at which C1 value, the green time G2 will equal to this condition. Okay, let's move with the question number 1. You will understand clearly after the solving this numerical. Okay, question number 1 says that the 15-minute traffic count on crossing road 1 and 2 during peak hour, please note this peak hour, are observed at 172, 142. So N1 here refer to road 1 and value of N1 is 172, means G1 will be higher as compared to G2 because N2 is 142 vehicle per lane, okay, respectively, approaching the intersection in the direction of heavier traffic flow. If the amber time required are 3 seconds and 2 seconds respectively for the two roads based on approach speed, design timing by trial cycle method, assume average time headway is given as 2.5 seconds during green phase. Okay, so let's start with this numerical with write down the given data. So we have, so here is the data given like this: n1 n2 time average headway in times and amber time 3 seconds and 2 seconds respectively. We will use this value after the calculation. Let's go with a step 3, which say that you have to assume your cycle length. So according to cycle length, we let assume the first trial. In our first trial, we assume our cycle length is 50 seconds. Okay, So 50 second we assume our cycle length. Now step 4 say, according to step 4, it say that your green time will be equal to 2.5 multiply 172, which is the count in 15 minutes, divided by 15 into 60 divided by 50 second. So this is the number of cycles in 15 minutes. According to this, we will get our answer for G1 is. So after solving this with 50 second cycle length, we will get the answer of G1 is equal to 23.88 second. And similarly for G2, we will change the N1 from N2 count and we will get 19.7 second. Now add these two values with 3 plus 2, which is the time for Amber. We will get our answer like this. So we will get our answer 48.6 second, which is not equal to our C1. The C1 we assume is 50 second. Now we change our C1 to some other value. So in second trial, we just use this as C2. In C2, we will use our cycle time is 40, which is 10 second less than from the previous cycle time. So everything will be changed here, like this will be changed with 40, this will be changed, this will also change, and after the last one will change. So we put 40 40. Now the solution will be, so after considering the cycle length 40 second in trial 2, we will get this answer for G1, this one for G2, and this is the final summation of C dash when we add 19.11 second with 5 second plus 15.7 second. This is you can take this one value because it is very near to 39.89. But let's take another trial, which is C3 or C3. We just assume this value 45, which is the average between the 40 and 50, which we earlier assume in previous trial. So there is a C3 which is 45. Now we use here 45, 45, and the answer will be, so in this case, we will get this type of value 21.5 second for G1, 22 for 17.75 for G2, and the overall is 44.25, which is near to the 45. But the 40 second, when the 40 second trial cycle length is more accurate. Okay, so you can go with the C2 cycle length. Now I am just rearranging these value in certain things so that we will get exact 45. Let's take this value is 22 second, and this one value is, since it is a trial based mechanism, so I can change this value to 18 second. Now we have G1 is equal to 22 second, G2 is equal to 18 second, and the amber light is 5. After the sum of these value, we will get 45 second exactly. Okay, so this is the concept behind the trial cycle method. Now we have like this, the phase 1 is equal to G1 phase 1 is related to road 1, so G1 having the higher value, which is 22 second, plus amber time for G1 or amber time for road 1 is taken as G plus red 1 plus red amber time. Okay, and it will be equal to 22, and this is equal to 3 second. This red time is equal to green time of the another route, which is 18 second, and red amber time is taken as 3 second. Or we can say this is the phase 2, which give the information for road 2 vehicle. So this amount is taken as the red time. So this is the red one, including the red amber. Okay, and this one is considered as green time, means we can assume that this is a G2 plus A2. Okay, so here this is red time 2 with red amber 2. So basically this, now we are going to draw the phase diagram for 1 and 2. In this manner we are going to discuss like this one. So this is represented with the road 1 diagram, and in this case the n1 value is 172. Whenever there is a green light appears for road 1, similarly the another leg of this road will also consider as green light. So these are the sign called traffic signs for road 1. Similarly, this is the traffic sign for road 1, and here is another sign which is indicate information for pedestrian. So this is a pedestrian sign 1. Whenever there is a green light for pedestrian, so they will be move in this direction. Okay, like this they will cross road 2, and for vehicle they will cross like this. At this position, the traffic signal 2, okay, the traffic signal 2 represent red light. The traffic signal 2 represent red light, as well as the pedestrian signal for road 1 represented by the red light. Now we are going to draw the phase diagram. We have length length we have 45 second. Okay, we have cycle length is 45. Out of 45, the red time for phase 1 is 18 plus 3. So we will draw this like this. Okay, and after red we have green time plus amber is 22 plus 3. So we will just draw like this. So this one have a greater length than the red one. So out of this 22 we have 3 for amber time. So we will just use like this. This is the amber one. And out of the red time 18 second we have some of the time for red amber time. So we will just mark with this one value. Now we can say that this is 0 second, this is 18 second. After 18 we will add 3 second for red amber, so it will count as 21. After 21 we will go with 22 second, so it will gives the 43, and this is the 45 second. Or in simple word, this is moving in this direction like incremental time cycle. And the uh, on the bottom side you can use, this is the 20 second, and sorry, this is 21 second, because 21 second, this one is related to your 22 second, and this one is 2 second. So this is the phase 1 diagram. Now we will draw for phase 2 diagram. So whenever there is a red line will be convert into green line like this, and after the green line this will convert into red light. Okay, so the amber here is 2 second, so we will provide here 2 second red amber light. Okay, this is red amber light, which is the transition zone between the green light and the red light. And here is a 3 second, just wait, sorry, this is 2 second basically. Okay, that's why 18 plus 2 is 40. This is 20, and here it will be 20, and this is the 45. Okay, now this is the complete. This is 20 and this is 25, gives the value is 45 seconds. Now this one value is equal to 20 and this one will be equal to 22, and the last one is equal to 3. So ember time is 3. So in this case we will just go through this. This is your 3-second red ember time, okay, and here is your ember time. Let me correct with this color coding, and this ember time is your 2 second, which is similar to the above one, okay. Here the green time is only 18 second, 18 second green time. Ember time is 2 second. Red time is 22 second. If we add these four value, 18 plus 2 plus 22 plus 3 second, we will get 45 second. So this is the correct representation of phase diagram. I hope you understand this question. And if you rotate this diagram in the clockwise direction, you will get the road to signal diagram, okay. The only change is this will be changed with N2, which is 142 vehicle per lane. So this is the completion of first type of method, which is trial based, and in next video we will move to approximate method. Thank you. Have a nice